Awesome. So with that being said, I want to introduce our speaker today. So Jim is the CTO at ModelOp, where he leads the technical design of ModelOp Center, the leading ModelOps platform, which I'm sure most of you at this point have probably heard of. Jim has been the technical innovator for the past 30 years, leading architectural design for products at a variety of companies, including Teradata, Qualtrics, and Novell. Jim holds two software patents and has taught several ModelOps master classes. For the last year, Jim has been living off the grid in the Rocky Mountains of Colorado. Jim, I'm jealous.
Yeah, thank you. Up here at 10,200 feet here today. So
I'm
hopefully the
sitting,
satellite holds.
I'm sitting right at sea level with two very loud children. So let me tell you, if I could go off the grid, I'd do it in a heartbeat. That being said, let me pass this over to Jim. Thank you so much. Again, thank you to everybody for joining. We hope you could as well join the Slack channel, the MLOps community Slack channel. And we have the MLOps world group there if you have any questions. So with that being said, I'm going to pass it over to Jim. And if you have any questions, throw them in the chat. We can get started. Thank you so much. Jim, take it away.
Great, thank you. Everyone, first of all, thank you for joining today, albeit virtually this time. Normally, we'd actually kind of schedule this as a little bit more of a hands-on exercise where we kind of break into teams and actually work hands-on on some of these life cycle items and go through them and take some examples maybe from your company to incorporate. But unfortunately, this year, not being in person, that makes that kind of a model very challenging, to say the least. So today, we're going to take more of a walkthrough approach, but we're going to do it in a fairly detailed manner. So we're going to go through a little bit of background up front about what a model lifecycle is, what even ModelOps as opposed to MLOps is, and then we'll go right into actually designing kind of a model lifecycle and looking specifically at three key areas of quality assurance of models, then looking at actual model monitoring and validation, and then finally looking at how do we ensure that models don't get lost in the system and continue to make predictions, et cetera, long after they should have been replaced, et cetera, as well. So we'll do that in a detailed manner. But first, what we're going to do is go through a little bit of background information so the exercise makes sense. And as I said, hopefully next year, looking forward, keep your fingers crossed and everything there, that we'll actually be able to do more of a hands-on kind of approach where you would actually build these yourself, and I would help you do that. So again, apologize for being a little bit more of a walkthrough this time, but I think hopefully you'll still get a lot out of it on that kind of thing. So with that, let me see if I get it to actually advance the slide. There we go. So basically, one of the key things here, what we're looking at today is, this is ML world and ML ops, and you hear a lot about that. But model ops, is kind of a superset of the capabilities that ML ops is. ML ops only applies to artificial intelligence / machine learning models initially, and then basically what really ModelOps does is it goes way beyond that. It first of all works for any kind of a model or an asset that's actually associated in making business predictions, including things like natural language, et cetera, and that kind of things, where and also more of the entire kind of business approach of what we need to do with these models that could run over months, potentially handle things like, government regulation, et cetera, on things like that. So we're going to be looking at model lifecycle flows that actually manage much further than what traditional just MLOps does, which is, heavily focused on the idea of model training and retraining and things like that as well, and that kind of things. So with that, example of a ModelOps architecture. Today, we're going to actually be using our ModelOp centers and ModelOp center services to actually live run what we're actually working with today. So you'll get some kind of a flavor of that. But the key aspects that are very different between a ModelOps solution and an MLOps solution is that ModelOps solutions really need to span across all kinds of different enterprise level capabilities and services processes that you already have within your organization. It's not specialized just for the training of models. It's really around things like creating tickets and ticketing systems, deploying using existing Jenkins infrastructure, using Jenkins infrastructure for scanning things like that, as well as like integrating with things like Ping Federate or publishing models into artifact repositories, or all of those different kinds of things. And likewise, because they are not in specific just for machine learning, we find that there's a large variety of tools that any organization may be using to actually implement their models, and we refer to those as the model factories. If it's a traditional kind of more of a traditional model, it could be based on Jupyter or RStudio. Of course, either of those could actually be used for machine learning too. But and then when we get into the machine learning space, we get into things like SageMaker, et cetera, and things like that as well. So basically, you really need to work with all of these different tools and provide them together into a ModelOps solution, much like when you're doing CI/CD pipelines with software. You can't really dictate a single development environment. We find the same thing when we go to that. And then finally, that we need to orchestrate these across the varieties of different runtimes that can run these things, because you may have Spark models, you may have SageMaker models. They kind of have to run on SageMaker depending on how they're implemented, as well as traditional Python and R models, and then TensorFlow models that are more raw, et cetera. They can be run on a variety of runtimes, including our own ModelOp runtime as well, and that kind of things on that. So really the whole idea here is becoming the ModelOps solution needs to be the conductor of the orchestra across all of these different solutions to actually track, and not only track, but drive the process of ensuring that the model meets all of the items it needs to do. We manage it, we know when to remove it, and we have all that kind of things. And creating also the idea of these immutable snapshots that says, yeah, this is the exact state of the model when it made this prediction, so that you can get into things like regulatory compliance, et cetera, as well as just ensure overall quality on that kind of things. So when you really look at all the different players that are coming together, ModelOp Center and any ModelOps based solution will kind of sit in the center of all these different things. You will go build your models and your experiments and all of those kinds of things within your model factory of choice, depending on what you're doing. So it could be Azure, Google, SageMaker, or just straight Python, or heck, even this BI with the GitHub instance on that is a valid form of model factory for doing that. Where ModelOps really come in is post development. So basically now this model, we believe it's ready to go. We've done our experimentation. We believe it's a quality model and it's ready to promote something in business. Then that's when we want to advance it and run it through a series of different steps that basically kind of leverage the existing integrations within an enterprise space to kind of move it through that. And then finally, actually at the very end, even report and visualize on that kind of things about what's going on. Supersana, could I get you to mute if you could? You're unmuted right now. If I get Supersana, Mr. Sarkar? Let me see if I can mute him. Hold on one second. There we go. I have the power. Sorry for the interruption there. So basically, the idea there is, at the very end, we even need to capture information overall about all the different models within your company and be able to report on that. What state are they in? Are they, how many are biased? How many are set to expire? All these different kinds of things, and do that leveraging all those kind of existing tools that are out there and that kind of things. But in specific, what we want to actually talk about today is the idea of a model lifecycle. As I said, a complete model lifecycle can be very sophisticated, like the example you see here. Don't worry, you're not going to be testing on that later. It's a bit of an eye chart. What we're going to be doing is working on much simpler ones today. And we're going to be working on a section at a time, so that we can see typically the kinds of things you might want to do to ensure the actual kind of quality of your and compliance of your models. So these things, when you look at them initially, a lot of people think like Airflow and things and data pipelines and things like that. This is not that at all. This is not designed to funnel data through a bunch of different models. This is really at a more of a business level, and typically these things will span, days or even months, on that kind of things, and they're designed to do that. So they're much higher level activities that provide that level of audibility about what has this model been through to proof it out. This is important when it comes to, later on when you're assessing model risk. If anything were to happen with a model where it was appearing to make a bad prediction, you have evidence that you put it through the rigor and you did your best effort to make this there. Or when it comes down to actually looking at government auditability type things where there's specific steps that must be done, things like models under the Frank Dodd Act or things like that, where you even have to go as far as showing the data didn't move 3 times before it went into the model. You have that trace of everything it's been through at your fingertips for that model at the time it actually made that request. So you have quite a record of what's there. So you're not going to want the kinds of things we're looking at here. Is we're looking at like completeness analysis. Are all the pieces there for the model and described so that we do know everything that went into this model, made up the model. Is it actually compliant with our security requirements? Does it have the right versions of libraries? Does it have the correct documentation that should be associated with the model? Because a lot of auditability says here's the rationale behind the model. We want to make sure that's there too, even though it doesn't execute the actual model. We still want to make sure that those are there and that kind of things. And stability. Did it run within the demo environment for like X number of days before it actually went on, and maybe did some in parallel testing with some of the data from production or something like that, and that kind of things, as well as ongoing. Is the model degrading? Do we need to do something about it? If the model is degrading, did we do something about it? Did we initiate a process, and what was that process, and how do we move that model back up there, and that kind of things. Additionally, we want things like, and eventually, a lot of people don't think about it, but traditionally, at some point, you're probably going to want to retire that model, and we're actually going to want to place that model in bed. Hold on one sec. Another individual there. All right, there we go. So basically, we're going to want to make sure that we have a replacement ready for that and that kind of things, as well as, it's key to have these integrations with those IT investments. For instance, what we're going to be showing today is one example is how do we actually use Jenkins to run a Veracode scan? Because a lot of places already have a standard in place and utilize Jenkins to pull in traditional security scans and things like that. And they have integrations there because maybe it isn't just models. They may do it on all their source code. So why not share those resources across all of those items on that, as well as when we come to human interactions, we don't want them having to come to our specific system necessarily to do that. Instead, we want to integrate with those existing investments like ServiceNow and Jira and things like that. And we'll be showing integration with Jira today and how we put that into the model lifecycle as well as alerts and escalations, as well as the centralized reporting on all those different models and that kind of thing are actually key. Now, how do we actually describe a model lifecycle? We want to do this in a programmatic manner. As I said, this is not simply documentation. What we show you today is actually going to drive each step of the process and ensure they happen. And then we're going to also record the fact of the steps we took through that process on that kind of things. To do that, there's already a known standard out there that's been out there for quite a while. It's called BPMN. It's actually XML under the covers, but in reality, it's everybody has a graphical editor. There's tons of different ones. We'll actually be using Camunda's editor today, but any BPMN 2.0 compliant editor can actually be used to generate that. So I wanted to briefly go over some of the items there, just because if you don't have familiarity with it, probably it'd be a little more confusing. So there's everything kind of starts or has an event process through it at some point. Start events actually kind of begin the process, and they can be things such as signals. We'll be seeing a lot of those today because ModelOp uses signals within that process. We communicate when things change in the model, like a new snapshot of the model has been created, or a job is completed, or all different, somebody changed something in Git, or all kinds of things like that. We can capture that information and actually use those to say, hey, we should now start the business process, including even custom generated signals. So you can have your own within your own company that to manually trigger. Likewise, there could also be timers for regularly occurring events. But what we often find again is that most larger corporations already have some kind of a scheduler system built in that's heavily tracked. So we tend to integrate with those and fire signals to actually fire those. And we'll be showing that kind of things today. And then, of course, a process eventually has to end. So, we have different ways where it can terminate. We can terminate it and it just ends normally, and that completes the process. We can also send out another signal to kind of chain processes and say, okay, we've completed this. Now something else must occur within that. And then, of course, a process can end in error as well. And then we're actually going to see one example today of an intermediate event. Those are kind of just events that happen in the middle. A great example of this is for promotion between our environments. We're actually going to pause for 7 days. Don't worry, not going to make you stay here for 7 days. We'll stop the demo before that process. But basically, the idea being that we'll actually you can use these to track long-running things. So it's got to sit in a test environment for 30 days. We can track that and then immediately kick on, and we'll show you how that works. And then also we can capture errors, like if any kind of an error occurs within any of the activities, which we'll talk about in a second, we can say what we should do. So we make sure we have full accounting on that kind of thing. So you'll see those circles up on the edge of an event. That's what those are actually doing. Likewise, the real workhorse where most of the things we're doing and where a lot of ModelOp ModelOp Center capabilities are exposed is through activities. There's user activities where it actually goes out and humans does things, and those have to wait for the human to complete, but we can track and we know who's doing it and things like that. So that's very important. We can see what it's waiting on, that kind of things. Script activities are great ways to just do a little something here and there. We can use any Java compatible scripts such as Groovy or Jython or any of those kinds of things, as well as we can use basically we can communicate to any external service. So some of those services are ModelOps services, which we'll be heavily demonstrating today. But additionally, we can call out to any existing service like a REST service, a SOAP service, any kind of a standard protocol, and interact with those. So even if you have custom things within your organization, you can incorporate those into your model life cycles. And then more importantly, you can also kind of bundle all this stuff together into sub-processes where you actually, can go through and share those within your corporation if you have standard ways you want to do things, but need to customize per group. And finally, there's the idea of gateways. And this is extremely important within BPM, in that we can make decisions about what we should do based on the current state of things. We'll be talking a lot about process variables and things like that today, where we do that, where basically we can use those activities to fetch information out of the ModelOp Center for information about the models and do stuff with them, and then actually make decisions based on what happens there. So we'll be seeing quite a bit of that there as well, and that kind of things. And those are typically done as exclusive gateways. We can also do things like forks and joins and things like that, which parallelize tasks, which we won't be going into in this exercise, but we can actually do make sure 15 things finish in parallel, and then wait for them to all complete. So standard kind of fork and join process on that kind of thing. So we have those as well. So why we want to do that is I want to get you familiar with the notation, because we're going to dive into the tool. So once again, don't worry about seeing this too closely, but I'm going to walk through the flows that we are actually going to go through in detail today and demonstrate and actually exercise as we complete each of the flows on that kind of thing. So we're going to first look at model validation on snapshot creation. Now, what we do there is snapshots to us are basically a version of the model. Once you create a snapshot, it is considered immutable. It can't be changed. And then it can be used for scoring, for deployment, for jobs, for all those kinds of things, so that we have that kind of immutability on that. Now, it's based off the current state of the model that you actually snapshot. So when we look at it and see what's there, we're going to actually kind of capture that information, all about what went into the model, any documentation about the time of the model, and the model code itself. and not allow it to be changed. So that way we can always get back to what made that specific prediction. But before we want to accept that for deployment, we really want to make sure there's a series of steps that have been completed on that. So we want to make sure first that all the necessary information is actually associated to the model. And we'll go through the individual items we're actually going to look for in more detail when we get into the tool. But the idea being we're going to do a completeness check first. And then we're actually going to basically go in and we're going to say, hey, we want to actually run a Veracode scan on this model and associate it with the model so that we can look back at it later and say, yes, in fact, a security scan was done of this model. Now, our company already has a Veracode instance set up and it's already scanning our software. So, we're going to leverage basically our integration with Jenkins to actually launch a job from within our system that actually launches a job in Jenkins. And we're going to track that and associate it right back to the model. So when we go to actually look at the model later, we'll be able to see those results directly within our system. And then finally, we're actually going to smoke test the model to make sure it actually executes. They provided us test data. We want to just make sure the thing actually runs on the target environment because, who knows, maybe they installed an unsupported library or there's some other anomaly that's there that just stops it from executing. So we're going to actually grab a simple test job, fire that off, make sure it completes. And this is all before we actually have any human actually look at it. That way they have some information at their fingertips and they know there's a certain minimum quality to that model that's already done for them, and all that information will be there. So then finally what we're going to do is say, hey, we've done the smoke test, we've ensured the model has all the pieces there, and we've done a security scan, they've all passed, and now it's time for a human to actually take a look and just review this and make sure that this model actually looks good. And I should point out at any time, if any of those others fail, we're going to take remediation action as well. We're not just going to say, oh, well, we're going to actually track that those problems are resolved for the model and do that. And we'll provide more details on that. So that's kind of the first step. And that's one that will have the most steps and will be a little bit more involved. Then second, what we're going to do is assume the model has actually now been deployed out into production on that kind of things. So how do we actually monitor this model and make sure that there's things? So we're going to show a simple example today of drift detection, where we're actually going to look at new incoming data, compare it against the model's specific associated training data that we'll have from the previous step, since we provided a pointer to that model within the model. And we're actually going to run an automated basically drift test against the model and get those results. And then we're actually going to use a DMN, the decision table that's again associated with the model, so it can be specific to the model rather than some generic parameters, and then actually test it, make sure it passes that decision table. But then most importantly from that, excuse me, if in fact it doesn't, rather than just again sending out an alert to who knows where, we're actually going to create Jira tickets within the within Jira that go back to the original developer to actually resolve and examine the issue. So not only are we doing some monitoring, but we're actually being proactive about making sure that if there is a problem, somebody does something about it, and we can trace it back to who looked at it, what the outcome was, and all of that kind of things as well. And this really helps to improve the overall reliability of the models, because obviously I think everyone understands in the MLOps world about the monitoring of models and being able to do that, but really because we're actually driving remediation if there is a problem as well, we can ensure that somebody isn't having to sit here and look for all these alerts, or they lose the email or whatever. We're going to make sure that there's actually accountability to fixing this model, and that we can track its replacement and compare back to the original and make sure the situation was actually resolved. So that should help a lot in making sure things are done in a timely manner. And then finally, we're also going to look at, for the model life cycles, we're going to look at ensuring that models are refreshed within production. So we're going to set a lifetime for a model. Now we're going to use an artificially low number of 30 days for us. Well, I mean, in some instances that may not be artificially low, but just basically, how do we ensure that not only is a model actually removed and expired when it is no longer considered relevant or refreshed most recently, but also ensuring and making sure that we receive notification of models that will be expiring, so somebody has a chance to deal with it before it expires, and somebody can receive notices and things like that. Again, we're going to do that through Jira today to actually pull that information in on that kind of thing, so that we do that. And finally, it's not really a model lifecycle, but I think it's a really important part of the whole ModelOps solution, is really being able to look at models from a business level as well across all of your models. So rather than often, as data scientists and such, we look at models as a very low level of, performance numbers, et cetera, and things like that. And we look at them on an individual or maybe a comparative basis. But really, what we want to know at a business level is not so much about the individual models, but where are all my models at? Compared to my actual goals for compliance across all kinds of models, performing all kinds of tasks, et cetera, on that. So I kind of know some of my potential liability and things like that. So, I know how are we actually using the models? Again, like we talked about earlier, how many are about to expire? How many are actually coming up behind and in flight and getting tests? How many basically are putting us at some level of business risk, and what's my exposure there, and that kind of thing. So we can get an awful lot of information there about that, and we're going to be showing that through utilizing Tableau to actually do that. So you can actually generate customized reports to your business rather than using a canned report that may or may not fit your business. And more importantly, you can use it within the tools people typically do. We support Tableau and Power BI, and you can have the corporate look and feel to it as well, which is very important as well when you're sharing these kinds of business reports, so that you can share them across the entirety of the enterprise and integrate them perhaps with other existing reports you may already have as well. So you can provide kind of a state of the union of all your models, either by a business unit across the whole company, or whatever makes sense from that standpoint. So we'll be showing a little bit how you can integrate with Tableau, with our system, to actually create those reports and leverage all this good stuff we're doing in the background, and be able to share it in a business level rather than more of a scientific level. So with that, we're going to get out of the slideware and we're going to jump into the actual real software here, where we're actually going to first look in detail at what goes into a model lifecycle, and then we'll exercise each one after we examine it, so you can kind of see them as to how they really work, to hopefully make things. Again, I apologize that we're not all in person and that kind of things, and can help build these, because I really believe building these hands-on is actually easier than, and frankly more interesting than the walking through them. But with where we're at right now, we'll do the best we can this time, and hopefully next time around we can actually build some of these together on that kind of thing. So what I'm going to do is bring up, as I said, that Camunda Modeler tool. Now, this is an eye chart right now, but I just want to show you it's broken to the different sections, and we're going to go through each of these different sections in detail, and how they work, and the kinds of things we want to actually accomplish, and where there's opportunities for other kinds of checks and things to do. Obviously, we're doing a limited amount here to try to make it somewhat understandable. We could always make it more understandable with that. Let me just make us a little bit more space there. I want to leave us a little there, but okay. So first of all, this is all going to start when we create a new snapshot. We talked about those signals. Well, when you actually create a snapshot within our system, which we'll show you how that's done and actually live walk you through that. It's really very easy. We're actually received a signal indicating which model has actually changed. So each signal carries with it a series of these process variables that we can then look at on there and that kind of things. So you'll see the first thing we do is actually grab the latest version of that model and put it in a deployed process variable on that kind of thing. So we'll pull it in and we're going to make some decisions. But what we're going to do is start really looking at this. I'll point out, you'll see these gateways. Remember, they make the decisions. So when we look at any of the paths, like we can see by default, we can actually look at things, and we're going to be using Groovy today. If you let me expand it, there we go, to actually be able to do that. So you'll see that that signal populates a deployable model variable that then we can look at any of the details of any of the assets, the associations, the metadata, et cetera, that you can put on a model. So for instance, we're actually going to look at tags for specific things. So for instance, what we typically do is here look at a business unit and say, well, for models that are headed to this location, we run it through this kind of a life cycle or things like that. So that's the determined applicability part. Because across the board, let me bring this up real quick here. The reality is you will have multiple model life cycles that handle different things within your organization. So you may have something that's going to the credit risk department that actually has to go through one series, but you may also have something that goes to fraud that has a different set of requirements. That's one of the reasons we use model life cycles, is because we can have a multiplicity of them, and they can be customizable by yourself. And uploaded into our system, because these things are not going to remain static. I'll tell you right now. I mean, I work in the mortgage industry for a little while. Every right during the height of the 2008 collapse, and every week it seemed a new regulation was coming out. Without having these kinds of things in a dynamic way that you can load it up, you're going to really struggle to keep up if you hand code and hard code these kinds of flows and these life cycles. It's not only that. I remember when going back, it's like we were with a bit of a smaller bank, and the kind of the game everyone would play is put a first version out and then see what all the big banks did, what Wells Fargo, Bank of America, all those kinds of places came out and did, and then you'd readjust to match what they did, because you figure they won't get sued, because you'd have things literally like I remember one case where they had a less than and a greater than, but didn't have an equal. So was the equal supposed to go in the greater than or equal, or less than or equal? I mean, some silly things like that in the law that don't really get clarified by lawmakers that the industry has to do. So really, when you get into these kinds of regulatory environments, it's going to change, and it's probably also the interpretation of what they actually wrote is going to change. So you need that kind of flexibility to do that. And also, if you have an internal model doing forecasting, probably don't want to run it through this kind of an ultra long process of what it's something that's under the same thing that's under a Frank Dodd Act. It needs a million steps. So you're going to need a multiplicity of those. So that's why we utilize this language to actually describe those and pull those in. So what we're going to do in our example for kind of a good example of the kinds of things you want to do is we're going to actually verify that certain assets are associated with a model. When you actually go and look at a model within the ModelOp Center, we have a very sophisticated way of describing a model. So let's look at an example of that to give you an idea of the things we're actually looking at here. So we'll look at we'll look at a XGBoost model here. We'll grab that one. So not only does it have kind of metadata about what it's on and where it is and things like that. In this case, this one's actually a SageMaker model, so we know where it was developed. But then there's going to be different assets associated with this model. Like for instance, there's the actual tarball that makes up this model in the case of a SageMaker model, as well as the required container that actually can run this model within that. That's a SageMaker model, but let's look at a more traditional kind of, we can look at let's see, I think I got an XGBoost model here somewhere where we can, let's grab, actually let's grab the Lasso model on that kind of things. And we can see it has a very different kind of set of assets. So it has things such as the source code, but it also has a decision table, which we'll talk about more later, but it has some test data associated with it. It has a weights file, it has a README for some documentation, training data, schema, et cetera, and that kind of thing. So, we have a whole series of assets that go with the model that aren't necessarily crucial to model execution, but really are for understanding the model and what it's doing out there in business. So before we allow the model to actually go to production, we're going to want to actually be able to verify that that kind of thing is there. So for instance, first of all, we just want a simple step to verify that there's documentation on this model. And now how we do that is we provide a delegate to actually examine each of the assets associated with the model in a wild-carded manner. So we're basically able to specify a multiplicity of items saying what it does. So for instance, we're going to look for an asset that has a README file because we've specified an input parameter, and we're going to do it for the deployable model that we're currently looking at. So with these activities, you can basically pass in input parameters and output parameters, and what that would drive it. Now we have full documentation on our delegates for what those input parameters can be on that. I won't bore you with the details of that. But each one, you can set those, and you can set those from process variables. So remember that deployable model we had earlier that came in on the signal? We can use that to actually set these. So that's kind of how you move things through the flow here of defining a model lifecycle, is you basically set these process variables, you can perform actions, and then they will output stuff. So in this case, when we're doing a verify of basically of assets on the model, if there are any assets that are missing, basically ones that if we don't find ones that match this, then basically we can go through and actually add them to the list of total missing assets. The reason we're adding them to a list is we don't want to go through and create a ticket for each and every single one that is missing, and we don't want to stop after the first failed one. So we're going to build up a full list of all the ones that are missing, and then actually go create a ticket telling the developer that they need to go add these items into the basically to their system in order to do excuse me, to their model, and recreate a new snapshot of that model. So in this case, we're looking for that README file and that kind of thing, which is what we're doing, is saying that it's got basic documentation. We could even say it has to have a PDF file and all other kinds of things as well. We're also going to make sure it actually has an input schema. So you can see where we're looking for anything with input and the type of model schema. We're going to make sure it has an output schema. Now, both of these in our system are specified in Avro. We can actually use these when you use our runtime to validate input and output records to make sure they match the required schema, but they also act as a form of documentation for others to actually implement data pipelines, et cetera, and make sure that we understand that this version of the model expects the data in this format when it's coming into it on that as well. And Avro is a great way to do that because, again, it's an industry standard, it's open, et cetera. So, we can do that. Likewise, it's very nice to have some smoke test data associated with the model. We want to make sure that there's something there. Again, as an exemplar of what the kind of data should look like. The schema is good, but pictures worth 1,000 words. So it's nice to have some actual data there. But also, we're going to use that to run just a simple short test on the model, create a job and run it, so that we can ensure that it actually does execute on the potential target platform. As well as we want to know the training data, because again, we want to do the drift testing. So we want to make sure that you provided a pointer to the data that this was trained on. Now in our system, in ModelOps Center, assets can be anything from an S3 bucket is a very common input file, but it could also be a SQL asset. So it could be a SQL statement, a parameterized SQL statement that actually got executed and was utilized to do as the training data. So again, we will have access to the exact data that it was actually trained on, such that we can do those kinds of comparisons against more recent data, against the original training data and things like that, as well as just a point of record of knowing that, hey, if we want to reproduce this result, that was there. And then finally, we want to actually have a test result comparator. And what that is actually a DMN file. Let me bring one of those up. I did not pre-open that up, so let me do that. Let me bring an example of what one looks like. So a lot of things, when you actually go to look at test results, a lot of systems will just look at individualized parameters, but as data scientists, we know it's rarely that simple. We usually need to look at a multiplicity of parameters, and often in conjunction. So it may be, if the false positive rate is less than this and the accuracy is less than this, then it should be great. The F2 should be greater than this. We want to compare multiple values, or even if we want to compare a value, we want to compare all of the values against a series of items and provide some meaningful reason back to the user as to how it does that. Within our system, what we do is we allow you to associate a decision table which you can use any DMN editor to do. DMNs, again, under the cover, they're just XML based, but that's ugly and hard to deal with. And I don't think anyone actually really wants to write that, although you can. But it's much easier to, again, to use a graphical editor to actually create these, where we can specify the scores. And these are not fixed within our system. They could even be your customized score. It's any score that your model puts out of its metrics function. We can utilize within these decision tables, and then you can specify thresholds. This one's really simple, but we can do, Booleans and et cetera. We can do more fuzzy comparisons as well, et cetera. We can even say, if the accuracy is greater than 99, we don't care. It always passes. We can indicate whether it passes or fails, and even provide a human reason as to why it fails. So when we later in this process that we're going through right now, actually go to execute one of our monitors, what's actually going to do in a back test is actually compare these and utilize this one that's specifically associated with the model to say, hey, yeah, for this model, does it pass? It's associated with the model rather than being some global setting. Now, you can have a global setting, but often we find, depending on the kind of model you're doing, you may have very different thresholds that are acceptable in the use case on that. So we want to make sure that one of those is actually there and in place. And if not, then again, this is where it comes back to the integration with enterprise solutions. Rather than going off and just sending off an email to somebody and who knows whether they see it, receive it, or whatever, we're actually going to go create a JIRA ticket. You see, we can specify the exact project keys and the types. So we're going to create a bug. We could be creating an issue or, different kinds of issues as well, stories, et cetera, as well. And we're going to say, well, when is it actually completed? Is it done? Is it reviewed? Is it whatever? And those can be any kind of the JIRA statuses that actually have, as well as creating the severity level of it. In this case, it is a hard error, as well as, we can say the submitted model is missing the things. We can provide something meaningful back to it on that kind of things, because then that gets us back to kind of the idea of model remediation. When we actually have a problem with the model, what do we do? In this case, for this demo, we're making it really simple. We're just going to store that notification and wait until they acknowledge that it has been reviewed. So it's going to wait for that exit status to actually occur. And we're going to go on. Now, in reality, we could say, hey, we actually want to do more. Like one of the exercises we do for together is I'd make you add in something where we actually make sure there's a replacement model, and the replacement model is specified and the snapshot is actually created and started before we actually exit this. So we can say, hey, yeah, they actually do have a replacement now in flight that resolves these issues on that kind of things. And that's very important to track, so we know it actually is resolved as opposed to do that. And it's very nice to do that within your existing enterprise assets as well on that kind of things. So that's the idea of the phase of that completeness check we talked about, making sure just all the pieces, parts we need to do to have the information necessary to know enough about the model are in place and do that. And obviously, you can drag and drop in new ones as you see fit to actually do that work and actually create those and add different ones and tweak them, and it's specific to your business on that kind of things. But then once we actually get the fact that we know all the pieces are there, then we actually want to do that idea of basically saying, okay, let's validate the compliance of the model. Now, we're only looking at one small aspect of compliance here. And then in this case, we're just making sure Veracode will scan the code for security issues, as well as if there are any libraries, et cetera, that it's actually using that have vulnerabilities or aren't up to our corporate standards on that kind of things. And this is where we utilize our basically our integration with Jenkins, where you can just create a Jenkins job very easily, where we'll actually can pass in any build parameters. So we're going to pass in the deployable model to the specific Groovy script that we're utilizing within Jenkins, the Jenkins Veracode plugin, so that we can actually fire that off. This could actually be a location of the model code itself, or any of those kinds of things as well. And you can easily pass that in through those build parameters to it, as well as you can provide the username it should run into. In this case, we are grabbing the security from Vault. So we're using credentials, a credential manager under the covers, because again, we integrate with things for these kinds of security items, and telling it where Jenkins is, as well as the Jenkins job name itself that gets created. That's kind of how Jenkins work, as a job name. So we have a Jenkins job out there called Veracode Jenkins that we're going to use to actually do that. And then we'll just actually wait for it to complete. And then we can actually look at that, status of the job. Is it, did it complete, or was it canceled? If it wasn't, then we're going to go out. If it basically errored, which means it didn't pass the scan, or if somebody killed it, we want to make sure it actually did complete. So again, we can go create Jira and go back to model remediation, so we can then track that whole process. So again, quite a level of detail here. But then once we actually do successfully pass that Veracode scan, once again, now we actually want to go and say, does this thing run? Because if it doesn't execute for some reason within the target runtime environment, we kind of want to catch that before, again, we spend anybody's time. It's kind of, all of this, you can think of as like running unit tests on some software source code, et cetera, automated from within Jenkins. You don't, we need to do more than that with a model, but we want to make sure that the developer immediately gets immediate feedback if they basically publish something that isn't up to snuff for whatever series of reasons. So we're going to go through and actually take that test data that we saw and actually create a test for running a job. Now we're going to run that on one of our ModelOp runtimes, which can run Java, Python, PFA, PMML, R, C, a multitude of different platforms in that. But this same process actually works with SageMaker. We can launch a job out there on that, or a Spark job. We can fire a Spark job onto a Spark cluster. So from the standpoint of the actual abstractions, a job is a job on this. So whatever the type of model is, it will locate the appropriate runtime and execute the model on that runtime. We're going to, as I said, use the ModelOp runtime to do that. All we have to do is basically we already created the job in this step on that kind of things, where we actually just basically, here we go, we just basically grabbing that test asset out of the code, and then we're actually going to just basically create for the deployable ID and set the input asset to that test asset, and then this delegate automatically just looks for the input asset and the deployable model ID, and we'll go create a job, run it, wait for it to complete, and actually use that DMN we showed you earlier to make sure it meets the minimum criteria if present. If it's not present, it's okay. It'll go on if that's allowed. That's why we verify it. It's there up above. But if it's present, it will actually make sure it basically passes that test on that kind of things, and we'll get a model test result within our system. And this, we talked about earlier, is a boundary event. So it basically says, hey, if any error occurs, again, so maybe it didn't run, libraries weren't there on that kind of things, et cetera. It just wasn't compatible with the runtime, or there's a bug in the code. It would actually, again, create a Jira notification, go back to the developer and ask them to resolve it, and so they can republish a new version. So again, we're not passive and just sitting back and watching these kinds of things. Instead, we're actually actively kind of driving and making sure that these things happen to completion on that kind of things. So then once it's actually done that, we're again going to look and see if it passed the test. If it didn't pass the minimum criteria, so let's say the accuracy was only 70% or something, then it will again create a review of the test notification. So this one's if the job just doesn't run. This one's if the test results don't meet the minimum criteria. We can actually move on and go through that and get that. And then finally, once it's actually passed, then we're actually going to create a human Jira review, and we'll show you what that looks like, where we can actually get linked to all this information we gather. They're going to see the jobs that ran. They're going to have all this at their fingertip. They can give it the once over, make sure they're happy with it on that kind of things. We'll know who reviewed it on that kind of things on that. And then basically they have the ability to approve it. Now, the neat thing, way we do approvals is we just look at the status of the actual Jira ticket. So if they basically completed in that, then it's considered reviewed. If they hit rejected or anything else, or needs more work, or etc., then it'll actually go back again to create a new ticket for them to actually go work on it and resolve those issues, and we can close it all out and bring it together. And then finally, we're actually going to go deploy it on our validation environment. where we're actually going to go set it, and it's actually going to start sitting on a RESTful interface and be ready to take live scoring and run that. And then we're going to actually say we're going to sit here and wait for 1 week. Don't worry, we're not actually going to do that. We're going to wait for the 1 week, and then we're actually going to go out and say after the week, we'll say, hey, here's another review notification to go back and look at the results over the last week. So it will have been running, it will have been being monitored, all that information will be associated with the model, and then somebody can actually look at it and that kind of things. And then once they approve it, again, very simplified process, we'd actually deploy to production, but when we actually deploy to production, we go out and utilize Jenkins to do that rather than this. So rather than the so you can kind of see the details and how this things, and this is where we would normally have you modify a few things on here and tweak them. But again, in the interest of the difficulties of the remoteness, we'll do is show it to you in action. So you can actually understand how it actually goes together. So we're going to go ahead and actually bring up that specific, there we go. It's the first one. That's why I missed it. Give me 1 second. So we're actually going to live follow along here and watch the process as it occurs. So what we're going to do is we'll bring up another instance of this window here, and we're going to actually go into a model. We're going to grab this lasso model we looked at earlier. What we're going to do is actually create a new snapshot, which will actually start the process. And what this does, this literally takes a snapshot in time of exactly the assets, the source code, everything that's there, and they won't be able to change it after that. The reason being that provides a step back auditability as to what was actually being used, and only snapshots can be deployed rather than the base model itself, and that ensures that any predictions that are made with something we can always get back to as a reference on there. Now these sources and stuff are typically when you look at them, they're tied to Git. So for instance, we capture things like the Git commit IDs and et cetera. So we even have that level of information as well on that particular model. So we have that in place. So now when we go and actually go create a snapshot, we could provide some additional more user-friendly name for the snapshot and descriptions, but we're not going to do that. Then we can say what the target runtime actually is. We're going to target ModelOp runtime in this particular case. And that's gonna, we could associate a model with it. And we'll look at those later. That's used for monitoring, where we could specify a drift monitor or a bias detection monitor or those kinds of things on that kind of things. And then it'll give us a final review of what we're gonna do. And I'm just gonna pull that off the screen real quick so we can follow along with what happens, because it happens pretty quickly here. So we're gonna go ahead and actually create that snapshot. And then when we actually create the snapshot, you can see it actually runs through. It ran through, it ran through and made sure all those assets were there, which it is. Now it's actually executing that Veracode job, and it's tracking it, it's waiting on it. So, we can actually go and see, for instance, if we bring that up, Jenkins is a little slow sometimes. So we can actually go here and actually track that within there. And we can see that the Jenkins job is actually running. So we can track it. It's created, it's still waiting for Jenkins to run it. As I said, Jenkins is slow, so bear with me on that. But our job extraction within the ModelOp Center can track all different kinds of jobs, be it Jenkins jobs or whether it's actually others. So we can see now it's actually done that. It could be a SageMaker job, it could be a Spark job, it could be a ModelOp job, and that kind of things. So we can see it's actually executing. It's executing the scan on the model right now, and now it's actually completed. So if we go back to the screen, we can see it's gone on. Excuse me. Now it's actually running the smoke test. So if we go back here, we can see it's actually running an instance of a job here on the ModelOps itself. So it's actually executing the Python code and running that on that, and that'll take just a second to run as well. We can see what's going on there with that and that kind of thing. Takes a minute to init for it to be complete. And then once that's complete on that, which should be in just a second, it will actually use the DMN to test the model results and actually ensure that it's there. And now we can see it's actually, I know it's small, but we can see it's actually waiting for Jira. So it's done that review. So you can see it's actually automated that full process of running through all those items, ensuring the quality, ensuring the completeness, ensuring the compliance of the model before we even get to review. And it drove that process. So ModelOp Center actually made all of those different assets talk together. Again, that conductor of the orchestra where it pulls them all together. So now again, rather than coming into our system to do these things, this is standard Jira. where we go on that. As a reviewer of the model, I can actually see I've actually got a review requested of the specific model. So I can see that it's actually been, the review has been requested. I can immediately get back to the information about the model and the specific snapshot. And the cool thing here is I can see, oh yeah, there's the different jobs that were actually run on that kind of monitor. So we can see, the job status of that Jenkins job. We can see that the run through the Veracode scan and see that, yep, it actually did complete successfully. So it ran a full scan on it and everything looks good there. We can actually look at the, let's see, I hit the wrong button. So it happens when you're doing the demo sometimes, where you can actually go through and see the individual test results on that kind of things and the raw test results. Now this one doesn't really put out very interesting metrics, but to give you the idea of the kind of test results we can actually capture in your system, I have one that puts out better metrics on that kind of things. We could have run things like simple, we can run interpretability scans, different kind of bias scans on that, being a reference group or just a standard group bias on that kind of things. We can look at kind of classifications, simple data drifts on it, on that kind of things, if we want to compare it against more metrics on that kind of things, as well as, we can look at stability analysis, et cetera, and those kinds of things as well. So we can capture a lot of information about the model. But most importantly, the idea being here that, I can link all of that directly to the version that I have being reviewed. I can make sure all of those items were run. And if there's any comparative models it's potentially replacing, we can even do kind of a champion challenger comparison of the model to look at, for instance, this one is I targeted to replace an XGBoost version. We can look at the different performance metrics in comparison as well to see how it actually performed on that kind of thing. So you can see as the reviewer, I can drive everything from Jira and actually manage that workflow from there, but I can have enough information at my fingertips to actually do that on that kind of thing. So make sure I'm on the right screen there. So now, again, the cool thing here is we can just mark this as complete within the workflow here, and then it'll actually progress on automatically from within there, actually get deployed out to that test environment on that kind of things, where it's now going to sit for a week. And as I said, we're not going to make you sit there for that, but we actually go look at the runtimes. We can look at the runtimes that are running it, and we can see the steps that this model has actually taken through to get there and how it got there, who reviewed it, all that kind of things. So we have auditability into what's actually running on that model version that's out there if anyone has any questions. And eventually after a week we get a ticket and we'd be able to go back and look at the additional jobs and monitoring, et cetera, that have been added to that things for a final review before moving it on. In reality, this is probably, this could be 30 days or 60 days or any kind of number of days. But we're always going to have insight as to what that model's been through and where it's there on that kind of thing. So that's kind of the more complex model lifecycle we're going to look at, but that's how we get it out to production. And obviously that's a key part of ModelOps, is making sure we have the information necessary that's there. We've run it through some rigor, we've ensured quality, we've tested it for a while, so we stop problems before it gets to production as much as we possibly can. Obviously conditions change, black swan event occurs, there's all kinds of things that we then need to cover of, okay, we put this thing through the rigor up front of bringing the models in, but now what do we do once it's out there? And that gets into that concept where I think we all know about, of things of such as model monitoring. So, we're going to look at next at a life cycle that handles the model monitoring phase, and this one won't take as long, so it's a lot simpler. So, basically, again, we're going to do that by using basically, we have the ability, again, same ones we use to verify, same delegates we use to verify that the items are present, we can also use to extract the item. So basically we can go through and say, hey, yeah, we want to find the training data on this specific model. So we're going to go through and actually do data drift detection on this. And then likewise, we're going to go out and actually grab the most recent, basically, data for that particular model, and that's as shown as a link to some comparator data. It's basically a landing bucket where the most recent data over X period of time has been landed, so we can use that to compare against the training data to look for that. And we actually have a single delegate you can use that actually basically just says, hey, use those two, that comparator data and that training data as the input assets, and use this deployable model ID to actually run it. And we're going to use look on it for an associated model. So what's an associated model in our world? Well, it has a series of different ideas. So we're going to look at a specific implementation of a model that we have here that already has an associated model on it. So basically, if we look at the details on this, we're going to see we actually have the ability to add basically data drift detection models. We have a whole library of these. So we have data drift detection, we have bias, we have et cetera. But more importantly, you can build your own, because there's new technologies coming out all of the time. So rather than being hard coded into our system, we have a bunch that are there out of the box. So just like that model there is a data drift detection model. We also have, oops, getting lost here as I talk and type at the same time. We also have the data drift detection models themselves are a managed model within our system that you can add and then just associate to a model. So then our basically life cycle out here is looking for that associated model of the specific type and going to create a job with that and run it and actually do data drift detection. And then again, it's going to use that decision table to look at the results. So the decision tables associated with the model. So the same process can work with all different kind of models. You don't have to have one per model. It's one per all different models, and basically the model itself specifies the criteria it's looking for. So we're going to look at make sure that all the tests actually pass against that criteria. And again, if it fails, we want some form of remediation. So again, we're going to create a JIRA ticket, simple one, and just make sure they acknowledge the fact that the model that it's been resolved. Of course, is that again, we could actually make sure a replacement is ready, or all kinds of different things, and then add on to this to add those additional steps. Now it's really handy that these are all just kind of drag and drop building blocks for doing that and that kind of things. But if it passes, we're just going to add a notification, not a JIRA notification, but just one to indicate that it's run and that it was successful. So we can look at that data later within Tableau on that, which is what we'll be doing to show how many are actually passing their tests as well as the ones that are failing. So we'll have that kind of remediation information. So again, it's a very, very simple tight flow that does it. But a key differentiator here is that we're going to have some kind of when something goes wrong, rather than just alerting and hoping something gets done, or relying on an external system, we're going to drive the ticketing system. We could just as easily put these things in a Datadog or something else like that as well, if we have a different remediation strategy. And that again, that's an advantage. We can even have group specific methodologies of remediation, et cetera. We can get as complex as we want here, but we don't want to just detect the problem. We want to make sure the problem gets solved is the key thing here on that kind of thing. So we're going to do that. So again, if we go back to this specific data, well, I have to go back to the actual model here. If we look at the consumer credit drift demo, again, I didn't want to wait all the time here to do that. So rather than looking at these live, we're going to go back and look at ones that have been running live in the background. We can see, in fact, all of the different data drift detections that have actually occurred. I have them running every 5 minutes. We're using a Quartz scheduler here, but this could just as easily be triggered by any external scheduling system. That's one of the reasons we use these signals on the outside, is we signal in the model ID we want to look at. So basically, any kind of external system, it's a RESTful endpoint you can just hit and provide the parameters, can actually start these processes, as well as including manual within our system as well. You can manually trigger these as well. We can see each of the drift detections that were actually done, as well as we can look at any of the individual results as well in this case, and actually capture the different p-values that were actually produced through this specific drift detector on that as well. So we have all of that information and can again show that yes, they were run every 5 minutes. Now, of course, it would be once a day, once a week, something more realistic. But when we go back to look at that model from an auditing perspective, we have the complete ability to do that on that kind of things. Then finally, on the model lifecycle side, before we get into kind of the business reporting side and what we can do there, we're going to look at the idea of basically how we actually check for expiration of models, but also try to get a little predictive about it. As part of the actual process creation on the snapshot validation, we actually, when they checked it in, if you'll notice, where is it? There it is. You'll notice we set an expiration date. So right within our process, when we checked in, after it had been reviewed, we set it, and we just did it for basically 30 days from now. Is what we did. Now, obviously, it could be a hard date, it could be whatever your business decides and needs, but we're actually able to say, hey, after review, here's this model will expire next days. We could make it more complex and say, this is a high risk model, so it expires quicker, and other ones expire later, or maybe slower, any kind of a logic that we want to actually put within there. But for this simple one, we set that expiration date. So then what we want to do is actually check every now and then and say, hey, these models, what ones are about to expire? So, we're going to actually do this. And we can simply say, hey, the expiration date, we're going to say basically now plus 15 days. So in other words, 15 days from now is when we want to get any models that are about to, any deploy snapshots of models that are about to expire within these 15 days. And we're going to basically say if they're currently deployed or they're currently initialized. So in other words, they're actually running out there on a system somewhere, and they're set to actually expire. For those, we're actually going to create a Jira one with just a warning with a bug to have somebody go look at it and say, yep, you better get on this. It's dying. But then likewise, then we're actually going to also say, hey, are there ones that are actually expired as of today? And for those, we're actually going to create an error and a Jira bug as well. And we could go as far as physically removing them, or other kinds of things. Although typically we wouldn't want to remove a model that's doesn't have a replacement in flight, but we could create any kind of a path we wanted. And again, that would be one of the exercises we did, where we expand upon this to actually go out and try to locate a replacement model on that kind of thing to actually make sure we could auto upgrade a model if there is one in flight in waiting that we see that is ready. And that's one of the hands-on we do, and hopefully we get to do next time around here when we're in person on that kind of thing. So we'll be able to do that. So again, to exercise this starts with the signal actually coming in. So I'm going to manually fire the signal just because it rather than running off of a Quartz process. This just makes it a little bit easier for us. So we're going to go to that MLC, and we're going to bring up that expiration. I always have a problem seeing these for some reason. There we go. Expiration process off screen here. I'm going to go ahead and actually fire that signal at it to actually run it. And when we fire it, you'll see it actually runs. Now, sure enough, I had purposely put a model in there before that was going to expire within 15 days. So you can see it actually detected that a model is approaching expired, but did not detect that any model was actually expired. So again, when we go back and look at Jira now, we can see that there's actually now I have a bug assigned to me that basically tells me that that model is going to expire in 15 days. I can sure enough go out and see which model that actually was and see the details on that process. That's this consumer credit approval model, and what has it been doing, et cetera. So we can see how it got installed in the quality process. And in this case, it said we actually use a model lifecycle to initialize our demo environment. So we can see it went through that process, and I can see any kind of jobs it's actually been through, as well as the most recent test results for this particular model. That's actually there as well. So we have information about that model, and I could look at it and determine, hey, that there's time for there's something in flight with that. So you can see how we've gone through the three major steps here of basically the idea of the model validation on the way in to ensure quality, make sure it's complete, and that we can do a quality review. And then we've gone and actually then monitored the model once it's running out there in production and made sure they're there, and then made sure we actually handled the kind of the expiration of models, like when we should be looking at replacements and what's there and that kind of things on that kind of things on that. And I'm going to briefly answer a few of these questions in the chat, but then we're going to jump right into Tableau as we're getting a little tight on that kind of things. I see that can this be integrated with Azure DevOps boards instead of Jira? Yes, absolutely. As I said, any kind of external process can actually, as long as it has some kind of a RESTful interface, can be done. So we do, for instance, integrate with like CloudWatch and SageMaker, et cetera, and things like that as well. So we do that kind of things. And the idea of a BPM engine to build the MLOps flow, we actually have integrated the BPM engine within the ModelOps Center solution. So that's canned in there. It already has the delegates. It's already all in place. We just use the BPM notation because it's already so advanced. Rather than inventing something proprietary on that kind of things, we use the BPM and notation that's out there to actually allow you to build it. But we provide a much higher level, because if you were to try to do this in just raw pure BPM, like even just creating a job would be very complex, or never mind communicating with SageMaker and things like that. For the GitHub, I do not have that online. That may be something we make available for these flows. I'll have to talk to about that on that kind of things. I can't live share this beyond this, just because I'm actually running this locally for efficiency. I didn't want things slowing down with video and Zoom and et cetera on that kind of things, And our platform is really addressing not only MLOps, because any of these processes could kick a training job, for instance, and do retraining and detection and things like that. It's really looking at the larger business flows that need to occur at a much, much, much higher level. There's so much that needs to be done, and they'll kind of segue well into looking at the Tableau dashboards from a business level, because what we really are trying to do at the end of the day is reduce risk across the entirety of the organization, et cetera, on that kind of things on that. And unsupervised versus supervised, absolutely. We've just been demoing some of the back testing type ones, but obviously things like drift detection stuff still do cover things of like variances of data from when the model was originally developed versus when it was actually deployed. So typically it doesn't necessarily need to be training data as the comparative data. It could even just be like a sample data set of these are the conditions of when I developed the model. Is this comparative to the conditions now, as well as also looking at basically. We showed some of them, but we don't only have to look at input data. We can look at variance in prediction results as well, of predictions from one point in time to predictions to another, and detect anomalies there to cover that unsupervised case as well. We literally have, I think, like 20 some odd different monitors that we have available that handle all these kinds of cases, from bias, from looking at concept drift versus data drift versus whatever. So yeah, absolutely, all of these can do it. We just tend to stick with the more classic supervised machine learning models for these kinds of demonstrations, because they're a little easier to follow and flow and have a few more things we can do. So it definitely does that as well on that kind of things. So then finally, let me grab a little sip of water. I've been talking for over an hour here. Let's look at Tableau. Now, a lot of solutions, when they go out to actually create these kinds of things, they basically, there's this canned dashboards and et cetera that kind of report like, especially data science level things and things like that, which is great. But when we really get into what we want to do, what we want to really look at is, some business level things when we get to the ModelOps solution as well. I'm going to briefly show you kind of more what would be a real dashboard for looking at things. We're not going to build something this sophisticated because we'd be here all day. But the idea is, we actually want to tap into the information within our system to actually be able to build these kinds of customizable dashboards. Like obviously, you're not going to want our logo on your dashboard. We may have different color schemes and things like that. But you're going to want different kinds of compliance pages, non-compliance, and they're going to be different issues based on what you're there. And then you're going to put them all back into that kind of a dashboard. So really what we did when we came to that, so as the home, but we may also want to do it by business unit as well, as to what's going on within different business units, what kind of models we have out there and stuff. So this is the goal, to have something nice and fancy that looks like this. We're obviously not going to build that in 10 minutes. So we're going to show you how to build a real simple case and how easily it is to do from within our system. So we're going to go ahead and actually just create a new window here. And what we do is, as I said, we integrate with both Tableau and Power BI. The way Tableau provides seamless integration is their idea through web data connectors. So we've actually implemented a web data connector here, where we can actually communicate directly to our system and actually bring the data from our system in. If we want to look at a specific model, we can do that to get their test data. But today we're actually going to look more across models across the board. So you can see where we have our individual data sources that actually talk to our models. So we're going to go ahead and bring in the stored models real quickly here on that kind of things. Then we're going to bring in those snapshots, and we can link those together within Tableau by the ID. And you can see there's a stored model ID, so we can provide the linking there on that kind of things. And then, we can even gather information about, any kind of those notifications that actually occurred there on that kind of things, because we had the deployable model ID into the deployable model ID. So we can bring all of those in, and then we can actually drag that information in from our system. So, it just directly communicates to the system. We can bring in all that metadata about the different models, what's there and that kind of things. The deployable models, we're going to go ahead and drag that information as well. So, we can see things like our expiration dates that we have within that, and we know what models are expiring, as well as those notifications. So we can see like what tests passed, what tests failed, all of that kind of things as well. How many error severities are there and what has failed out there, so that we can build up the individual sheets. So you can see how easy it is and seamless to communicate with our system to do that. So we're going to go ahead and actually build a very quick example here of how to do it. So for instance, let's bring in, we're going to make a simple pie chart as an example. One of the ones that was actually on the other more complex dashboard, where we actually can say, hey, let's add a new calculation. We're going to take a count of, actually, no, we'll start with model. We'll just look at the different kinds of models we have in our system. So we're going to drag that, and we're going to make that our color that we actually have out there. And then we can go in and actually say, well, how many of these things do we have? So how many of different model types do we actually have? So we can go out and say, hey, there's a count of the model types, and we'll make that our pie chart there. And then we want to actually be able to read something there. So we can add in a label again of model type. Oop, if I can type correctly on that, and bring that in and make that a label on that. There we go. And even, let's say that's great to have all the different kinds of names, but it's nice to have a little bit more information in there. So let's also go back to that count of model type. What we're going to do is enhance that a little bit. We'll make it a label, and then we're actually going to edit. Whoops, what did I must have fat fingered something there. Yep, fat fingered and arrayed. There we go. So then what we're actually going to do is make it a little bit nicer. We can actually go in and say, yeah, it's percent of total at the level there. So we can actually bring that in, and let's increase that size a little bit so you guys can actually see it on that kind of things. So you can see how pretty quickly we can actually build up information directly from the model metadata that's contained within there to put together any kind of a custom graphic within an overall dashboard. So, we can pretty quickly and easily pull information about the models. We can pull information from the actual notifications about the test results. We can even pull in test results themselves and graph those over time, et cetera, if we want as well within reports. So you can have these that automatically get live updated. You build up the report, then you just do that update of the data, and it'll automatically get there, and then you can share those across your business. So rather than us dictating one, as I said, like the one I showed you earlier, right here is one we actually provide to you, already constructed, already complete. So you can just tweak it and change a couple things if you want to actually kind of get the higher level kind of MRM compliance level stuff that you actually want. Or, you can start from scratch and build your own, or, add an extra page or an extra calculation or those kinds of things as well. It's not hard to do, and you do these within best of breed tools like Power BI and Tableau, such that you already most organizations already have something like this in place in order to be able to share. So not only do we have the model ops side of the world covered, where we're shepherding the model through the business, we're actually making sure it's up to compliance, works correctly, is monitored over time, then eventually retired. We also have a nice way to look across all of our models and have a single pane of glass across all the models within the company as to what's our risk, how many are out there, how many are going to be expiring, how many to have the replacements, what workload do we have, what's the potential cost. I could bring a cost factor into any of these calculations within there as well, so we can understand cost of the business if we don't do something about this kind of things as well, and that kind of thing. So it really provides that overall powerful solution of being able to flexibly define all of these things across all of the items, get that single pane of glass as to what's going on, understand jobs that are running all over the place on SageMaker, on our just regular Python or R, those kinds of things, as well as Spark, et cetera, on all different kinds of things, and track their progress on where things are going and what's going on live out there, what's been run on a model, where's it at, what was its state when it made this prediction. I've got something deployed and it's actually running out there. What did it actually go through to actually verify that it should be running out there, et cetera, et cetera. So, you really do have that full level and power of information to monitor a model, and not only monitor it, but also make sure it's good, make sure if there's a problem, it gets resolved, and really increase the quality and continuous delivery of your models within the business. Because the real goal is, a model sitting on a data scientist desk is not doing any good. You're not seeing any value out of it. We want to make sure they get out there correctly, and they get out there with high quality and really deliver the business value that's supposed to, and then be able to prove that the models are compliant, but also they are delivering the business value. We can tie it back to that and back to the original development organization and show the impact to the business in the long run through the complete solution. So with that, I did want to leave a few minutes for questions at the end here. If anyone had any questions about anything they see before, as I said, hopefully next year we'll get to do this live and in person. It's a lot more fun when you actually get to work on these yourself rather than just watch me move around. And that's why we didn't do a whole lot of live coding today, because that's can be like watching paint dry. So we decided to take you on a tour instead of what the details of the model lifecycle. So with that, are there any questions? You can either, I guess, ask them live or put them in the chat. Okay, I'm not seeing any questions here. So I guess with that, we can conclude the demo if there's no questions. And thank you very much for your time. And I hope you enjoyed the platform. Oh, I got one question that actually did come through here. Let
Got a
me answer
couple
that one real
to
quick.
the backlog there, Jim.
I think I answered all
Oh,
of
yeah.
those in between. I took a pause in the middle. I apologize for that. But basically, yes, this absolutely runs on the cloud. We are container agnostic. What you saw today was running on Kubernetes. On that kind of things with Docker containers. We run on Azure, we run on OpenShift, we've run on Amazon, we run on large variety. We're not tied to any particular container orchestration methodology. We technically could run on-prem, but that's not our normal pattern. It's absolutely something we could do. We do usually like to work with a containerized framework given its microservices, but we are not tied to any specific one and have deployed across many different containerized systems, both on-prem cloud, off-prem cloud, traditional hosted. We do not do SaaS. We are not software as a service. We typically deal with too much sensitive data and PII. So we typically view it as our system does not store that PII data, it references it. So typically to have those kinds of references, you'd want a very secure solution. So we prefer to go with a private cloud kind of solution. Were there any other questions out there? No, looks like perhaps we're wrapped up there. You're on mute.
There we are. Thank you very much,
There you
Jim.
go.
I really appreciate you joining, and thanks everybody for tuning in for this session. Jim, I hope to have you come join us in person, hopefully for next year when we run this again. That'd be great to have you.
Yeah, looking forward to it. Absolutely looking forward to it.
And for those who are joining and plan to attend the rest of the sessions, tomorrow we have another day of workshops. And again, Wednesday, Thursday, we will have the conference talks on the workshop channel. So, sorry, on the conference platform Hopin. So you will have access to that. We'll send a link out tonight. So keep an eye out for that, and that will allow you to join the conference platform Hopin. Great. So thank you so much, everybody. I hope you enjoy. I'll leave this on in case anybody has any last minute questions. I'm sure you can reach out to Jim, and the videos and whatnot will be sent to you afterwards as well. So thank you so much, everyone. Hope you enjoy.
Okay, yeah, I see a couple other questions that came in. I'll answer real quick. Basically, can we use Power BI? Yes, absolutely. It's a slightly different form of integration. We use their data connector infrastructure, which looks very different. Frankly, is a little more powerful and that can handle more complex data than Tableau can. Tableau likes table format data where you can use more of an object format data with Power BI. So we do have integration for that as well. The data, we actually just reference data very on purpose. We are not a data management platform. We don't intend to be. We believe there are best of breed solutions out there already to provide for that. So we provide links to it. So for instance, it could be HDFS, S3, Azure Blob Store, any of those kinds of things. And typically data platforms already integrate with those infrastructures, and then we store a reference to them. Or as I said, it's things like SQL or Snowflake or others that we do have support for as well. We store those as parameterized assets. So if you design your queries to be repeatable on that kind of thing, such as with dates, etc., you will always get the same results from the same query, and we can utilize that as well on that kind of thing. So the data is purposely not exposed from within our platform. Instead, we do that, and then to access the data for the runtimes, either the runtime already has that built in the case of things like Spark, or we can use things like Vault or IAM in the case of Azure, in the case of AWS, etc. So we integrate in that level as well and that kind of thing. So it's a very purposeful strategy because of PII and also the storage requirements when we get into large training data sets. So were there any additional questions here in the last few minutes? Okay, looks like we've answered all the questions here. Again, thank you so much for the time today that you spent, and I hope it provided you a view into the ModelOps world and what we do at modelop.com to basically provide a solution that's tailored to just this space, as opposed to being integrated into a model factory where you have to use that model factory. We span all the model factories and basically allow you to manage the models consistently, no matter what the development platform. So again, thank you very much for your time today, and I look forward to hopefully seeing you all in person at a future date here. So, yeah, thank you. Take care, everyone. Goodbye.